Sure.
Good morning students. 12th Maths, second chapter, complex numbers. Basic algebraic properties of complex numbers. Properties of complex numbers. So these are the properties, addition and multiplication. So in addition, we have the closure property, and multiplication also we have the closure property. So closure property for addition, z1 plus z2. For multiplication, z1 into z2. Commutative property, z1 plus z2 equal to z2 plus z1. And for multiplication, z1 into z2 equal to z2 into z1. So for associative property, z1 plus z2 plus z3 is equal to z1 plus z2 plus z3. For multiplication, z1 into z2 into z3 is equal to z1 into z2 into z3. Additive identity. So z plus 0 is equal to 0 plus z, that's equal to z. Multiplicative identity. So z into 1 is equal to 1 into z, that's equal to z. So additive inverse. So z plus minus z is equal to minus z plus z is equal to 0. For inverse of additive inverse of z is minus z. So if you multiplicative inverse of z is z inverse. That is z w is equal to w z equal to 1. So where w is equal to z inverse. The value of w is denoted as z inverse. So again, one more property is there, distributive property. So z1 plus z2 into z3 is equal to z1 into z3 plus z2 into z3. Next one, z1 into z2 plus z3 is equal to z1 into z2 plus z1 into z3. This is the distributive property. Next we move to the problems. So exercise 2.3. First question, if z1 is equal to 1 minus 3i, z2 is equal to minus 4i, and z3 is equal to 5. Show that first one, z1 plus z2 into plus z3 is equal to z1 plus z2 plus z3. Solution. First we have to write all the given datas. What are the given datas? So z1 is equal to 1 minus 3i. z2 is equal to minus 4i. z3 is equal to 5. Okay, now we can take the first part, that is LHS value, LHS. So z1 plus z2 plus z3 is equal to z1 value, substitute the values. Substitute all the values z1, z2 and z3. So 1 minus 3i into plus minus 4i plus Z3 value is 5. So 1 minus 3i plus into minus minus 4i plus 5. That's equal to 1 minus 3i minus 4i plus 5 equal to 5 plus 1 6. 6 minus 3 plus 4, the value is 7. 7i. Take this as equation 1. Then we have to take RHS value. So RHS Z1 plus Z2 plus Z3 is equal to, substitute the value, Z1 value 1 minus 3i, 1 minus 3i plus Z2 value minus 4i plus Z3 value is 5 equal to 1 minus 3i plus have to remove the brackets. So here plus is there, so minus is here, so plus into minus, the value is minus 4i plus 5. That's equal to 5 plus 1, the value is 6. 6 minus 3 minus 4, the value is minus 7i. Take this as equation 2. From 1 and 2, hence it is verified. Have to prove both sides are equal. So from equation 1 and 2, Z1 plus Z2 plus Z3 is equal to Z1 plus Z2 plus Z3 is equal, hence proved. So this is the answer. So next, second question. Second question, if Z1 is equal to 3, Z2 is equal to minus 7i and Z3 is equal to 5 plus 4i, have to show that first part Z1 into Z2 plus Z3 is equal to Z1 into Z2 plus Z1 into Z3. Solution. So have to write the given values. So first write the given data. So Z1 equal to 3. Z2 is equal to minus 7i and Z3 is equal to 5 plus 4i is the given data. Then have to prove. So take LHS value first. So Z1 into Z2 plus Z3 equal to Z1 value is 3 into Z2 value minus 7i plus Z3 value is 5 plus 4i. That's equal to 3 into minus 7i plus, have to remove the bracket, plus 5 plus 4i equal to 3 into, so 5 minus 7 plus 4, the value is minus 3i. That's equal to, multiply 3 into 5, 15 minus 3 into 3, the value is 9. 9i. Take this as equation 1. Next, we can take RHS value. So Z1 is into Z2 is plus Z1 into Z3 is equal to, right, Z1 value into Z2 value is minus 7i plus Z1 value is 3 into Z3 value is 5 plus 4i. That's equal to, so 3 into minus 7 value is minus 21i plus, we can multiply 3 into 5 value is 15 plus 3 into 4 the value is 12 I. That's equal to 15 minus 9i. Take this as equation 2. From 1 and 2, hence it is verified. Both the values are equal. From 1 and 2, from equation 1 and 2, Z1 into Z2 plus Z3 is equal to Z1 into Z2 plus Z1 into Z3. Hence, proved. So this is the answer. Third question. If Z1 is equal to 2 plus 5i, Z2 is equal to minus 3 minus 4i, Z3 is equal to 1 plus I. Find the additive and multiplicative inverse of Z1, Z2 and Z3. So now if Z1 value is given, Z1, Z2 and Z3 value is given, find the additive and multiplicative inverse of Z1, Z2 and Z3. Additive inverse is for Z, the additive inverse is Z, the additive inverse is minus Z. For multiplicative inverse, so Z is equal to 1 by Z. This is for additive inverse, this is for multiplicative inverse. So first we can write the given data. So Z1 is equal to 2 plus 5i, Z2 is equal to minus 3 minus 4i, Z3 is equal to 1 plus I. So first we can find additive inverse. Additive inverse. So for additive inverse, Z is equal to minus Z. Okay. So first one, Z1 equal to the value is 2 plus 5i. So for minus Z1 is equal to minus into 2 plus 5i. That's equal to minus 2 minus 5i. Next, Z2 is equal to, what is the value given? Minus 3 minus 4i. So additive inverse minus Z2 is equal to minus Z2 value minus 3 minus 4i. That's equal to multiply minus inside. So minus into minus plus 3 minus into minus plus 4i. So for Z3 equal to what's the value? 1 plus I. So inverse of Z3 is, so Z minus Z3 is equal to minus into 1 plus I. That's equal to minus 1 minus I. So this is the answer for additive inverse. So next we can find the multiplicative inverse. Multiplicative inverse. So Z1 is equal to 2 plus 5i is given. So inverse of Z1 is Z1 inverse, that's equal to 1 by Z1, that's equal to 1 by 2 plus 5i. If the denominator, if you have the complex number, you have to take the conjugate. So that's equal to 1 by 2 plus 5i into 2 minus 5i divided by 2 minus 5i. That's equal to, so 2 minus 5i divided by, you can use this formula a square minus b square formula. A square minus b square is equal to a plus b into a minus b. You can use this formula, the denominator. So a square, the value is 2, a value is 2, b value is 5i. So 2 square minus 5i the whole square, that's equal to 2 minus 5i divided by 2 square value is 4 minus 5 square, the value is 25i square. That's equal to 2 minus 5i divided by 4 minus into this I square value is, so right almost 4 minus 25 into minus 1. I square value is minus 1. That's equal to 2 minus 5i divided by 4 minus into minus plus 25. That's equal to 2 minus 5i divided by 4 plus 25, the value is 29. So that's equal to, so we can take this 29 outside, 29 into 2 minus 5i. This is for Z1. So next we can find for Z2. That's equal to, Z2 the value is minus 3 minus 4i. So Z2 inverse is equal to 1 by Z2, that's equal to 1 by Z2 value is minus 3 minus 4i, that's equal to, we can take the conjugate for the denominator. So 1 by minus 3 minus 4i into, so conjugate minus 3 plus 4i divided by minus 3 plus 4i, that's equal to, so minus 3 plus 4i divided by, you can use this formula a square minus b square. So minus 3 is a and 4i is b. So minus 3 is the whole square minus 4i the whole square. That's equal to minus 3 plus 4i divided by, so minus 3 whole square, the value is 9 minus 4 into 4 square, the value is 16. 16 into I square. That's equal to minus 3 plus 4i divided by 9 plus 16. Because I square value is minus 1. Minus into minus, the value is plus. So 9 plus 16, that's equal to minus 3 plus 4i divided by 25. Next we can find for Z3. Z3 is equal to, Z3 value is 1 plus I. So Z3 value is 1 plus 5. We can find the inverse. So Z3 inverse is equal to 1 by Z3, that's equal to 1 by Z3 value is 1 plus I. Take the conjugate, that's equal to 1 by 1 plus I into 1 minus I divided by 1 minus I. That's equal to 1 minus I divided by, use this formula A square minus B square. So A value is 1, B value is I. 1 square minus I square. That's equal to 1 minus I divided by 1 minus 1. Because I square value is minus 1. So 1 minus I divided by 1 plus 1. That's equal to 1 minus I divided by 2. This is the answer for Z3. So now we can move to the next topic, conjugate of complex numbers. So conjugate of complex numbers, we have the properties. Note on the properties. So properties of complex conjugates. So I have 10 properties. First one, Z1 plus Z2 the whole bar is equal to Z1 bar plus Z2 bar. Second one, Z1 plus Z1 minus Z2 is equal to Z1 bar minus Z2 bar. Third one, Z1 into Z2 bar is equal to Z1 bar into Z2 bar. So the fourth one, Z1 divided by Z2 the whole bar is equal to Z1 bar divided by Z2 bar. When Z2 is not equal to 0, denominator value is 0, it's not defined. So Z2 value should not be 0, it's not equal to 0. Fifth one, real part of Z is equal to Z1 Z plus Z bar divided by 2. Sixth one, imaginary part of Z is equal to Z minus Z bar divided by 2I. So now listen. So first one, Z1 plus this is addition, subtraction, multiplication, division. So real part of the Z, imaginary part of Z. So Z1 plus Z2 the whole bar is equal to Z1 bar plus Z2 bar. Z1 minus Z2 the whole bar is equal to Z1 bar minus Z2 bar. So Z1 into Z2 the whole bar is equal to Z1 bar into Z2 bar. So Z1 divided by Z2 the whole bar is equal to Z1 bar divided by Z2 bar, where Z2 not equal to 0. So real part of Z is equal to Z plus Z bar divided by 2. Imaginary part of Z is equal to Z minus Z bar by 2I. Seventh property, Z10 bar equal to Z bar the whole power n, where n is an integer. So eighth one, Z is real if and only if Z is equal to Z bar. So So ninth one, Z is purely imaginary. If and only if Z is equal to minus Z bar. 10th one, Z double bar is equal to Z. So Z power n the whole bar is equal to Z bar the whole power n, where n is an integer. The n value should be an integer value. So Z is real if and only if Z equal to Z inverse. So Z bar, Z is purely imaginary if and only if Z is equal to minus Z bar. Z double bar is equal to Z. So we move to the problems. Example 2.3. Write 3 plus 4i divided by 5 minus 2i in the x plus I form. Hence, find its real and imaginary part. So you have to find the real part and imaginary part. Solution. So Z is given, hence you have to find the real part and imaginary part. So Z is equal to x plus iy. So 3 plus 4i is equal to 3 plus 4i divided by 5 minus 12 into, have to take the conjugate. So what is the conjugate of 5 minus 12y? So 5 plus 12y, 5 plus 12y divided by 5 plus 12i. That's equal to multiply 3 plus 4i into 5 plus 12i divided by, so use the formula a square minus b square formula. So 5 square minus 12y the whole square, that's equal to, multiply this term, product 3 into 550 plus 3 into 12 by 36i, then 4 into 4i into 5, the value is 20i, then plus 4i into 12i, the value is plus 48i square divided by 5 square, the value is 25 minus 12 square, the value is 144 into I square. That's equal to 15i, 36i plus 20i minus 48. I square value is minus 1 divided by 25. I square value is minus 1. So minus into plus. So minus into minus plus. So plus 144. That's equal to minus 48. Minus 48 is minus 48 plus 15. The value is 30 minus 33 plus 36 plus 20. The value is 56 I divided by 25 plus 144. The value is 169. That's equal to minus 33 divided by 169 plus 56 I divided by 169. Which is the real part and which is the imaginary part? First part is real and the I part, if you have the I part, means that is the imaginary part. In the question, what they asked? So real part and imaginary part. So real part is equal to minus 33 divided by 169 and imaginary part is equal to 56 divided by 169. So this is the answer for example 2.3. Next we move to the next example 2.4. Simplify 1 plus I divided by 1 minus I the whole cube minus 1 minus I divided by 1 plus I the whole cube into rectangular form. Solution. So rectangular form, what is the rectangular form? That's z equal to I plus, z equal to x plus I1. So I have to find, first we have to find the first part, that is 1 plus I divided by 1 minus I. Second we have to find this part, then we have to subtract both the values. So 1 plus I divided by 1 minus I is equal to 1 plus I divided by 1 minus I into, take the conjugate for the denominator. So 1 plus I divided by 1 plus I, that's equal to 1 plus I into 1 plus I divided by, use the formula, so 1 square minus I square, that's equal to multiply. So 1 into 1 plus 1 into I plus I square divided by 1 minus I square, the value is minus 1, that's equal to 1 plus 2I minus 1 divided by, so I square value is minus 1, so 1 plus 1, that's equal to, so this plus 1 minus 1 cancel, so 2I divided by 2, so we can cancel 2. So what is the answer? That's equal to I. This is for first part. Next we have to find for second part. 1 minus I divided by 1 plus I, that's equal to 1 minus I divided by 1 plus I into 1 minus I, conjugate of 1 plus I is 1 minus I divided by 1 minus I, that's equal to 1 minus I into 1 minus I divided by 1 square minus I square, that's equal to multiply. So 1 minus 1 into minus I, the value is minus I. So minus I into 1, the value is minus I. Minus into minus plus I into I square divided by, so 1 minus 1, that's equal to 1 minus I minus 1 divided by 1 plus 1, that's equal to, cancel both these values. So minus I into minus I, the value is minus 2I divided by 2. Cancel this 2, that's equal to minus I. So now we can substitute the values. Okay. So 1 plus I divided by 1 minus I the whole cube minus 1 minus I divided by 1 plus I the whole cube is equal to, have the value. So I cube minus, so for this term what is the value? Minus I. So minus I the whole cube. Okay, that's equal to I cube minus into minus plus I cube, that's equal to I cube value is minus I, here also I cube value is minus I, that's equal to minus 2I. So this is the answer. Minus 2i. So this is the answer for, so example 2.4. So next we move to the next problem. Example 2.5. So example 2.5, write the question. If z plus 3 divided by z minus 5y is equal to 1 plus 4i divided by 2, find the complex number in the rectangular form. So solution. So if the question is given, find the complex number z in the rectangular form. Okay. Complex number z in the rectangular form. Z plus 3 by z minus 5y is equal to 1 plus 4i divided by 2. So cross multiply. So 2 into z plus 3 is equal to 1 plus 4i into z minus 5i. Multiply 2z plus multiply is 2. 2 into 3, 6 equal to. So 1 into z minus is minus 1 into 5, 5i, then plus 4i into z. 4i into minus 5i. So plus into minus 4 into 5, 20, I into I square. So 2z plus 6z is equal to z minus 5i plus 4zi. So I square value is minus 1. Minus 1 into minus plus 20. So we can take this z term in one side. So 2z minus z minus 4z is equal to, so 4zi is equal to minus 5i plus 20 minus 6. Take the z term one side. So 2z, if we change the sign changes. So minus z minus 4zi is equal to minus 5y plus 20 minus 6. So take z outside. So z is common for all the three terms. So z into 2 minus 1 minus 4i is equal to minus 5i plus 20 minus 6. So z into 2 minus 1, the value is 1. 1 minus 4i is equal to minus 5i plus 14. That's equal to, z is equal to, we can take this term in the denominator. So 1 minus 4i divided by minus 5i plus 14. That's equal to, take the conjugate for the denominator. So we can write the real part first term. Okay. So 14 minus 5i. That's equal to 1 minus 4i divided by 14 minus 5i into, so what is the conjugate? 14 plus 5i divided by 14 plus 5i, that's equal to, multiply 1 minus 4i into 14 plus 5i divided by, use the formula, so 14 square Multiply this term. 1 into 14, 14, 14. So 1 into 5i plus 5i minus 4 into 14. 4 into 14 is the value 16. 4, 5. 56 I minus 4i into 5i minus 20i square divided by, so 14 square, the value is 14 square value is 16. 4 4s are 4, 1 4 is 4, 4, 5. 196. Sorry, 1 minute. So 14 square the value is 196 minus 5 square the value is 25 into minus 1, that's equal to 14 plus 5i minus 56 minus the minus plus 20 divided by 196 minus the minus plus 25. That's equal to 14 plus 6, what is the value? So 34 plus 5 minus 56 value minus 51i divided by 196 into 25. This is the value 11. So 9 plus 1, 10. 12, 1, 222. That's equal to 34 divided by 21 minus 51i divided by 221, that's equal to, so if we cancel, what is the value we will get? One minute. Sorry for the mistake. 1 minute. So z is equal to 14 minus 5i divided by 1 minus 4i. Okay, that's equal to 14 minus 5i divided by 1 minus 4i into 1 plus 4i divided by 1 plus 4i. That's equal to 14 plus 56i minus 5i minus 20i square divided by 1 square minus 4i the whole square, that's equal to 14 plus 56i minus 5i plus 20, that's equal to 1 minus 16i square equal to 34 plus 51i divided by 1 plus 16, that's equal to 34 plus 51i divided by 17, that's equal to 34 divided by 17 plus 51i divided by 17. So if we cancel, we will get, so So cancel, you will get 2 here. Cancel, you will get 3. That's equal to 2 plus 3i. This is the answer. So the previously I made a mistake. So have to take down this. So z value you will get 14 minus 5i divided by 1 minus 4i. Then you have to take the conjugate. Okay. Next example, 2.6. So if z1 is equal to 3 minus 2i, z2 is equal to 6 plus 4i, find z1 divided by z2 in the rectangular form. In the rectangular form. So z1 solution, z1 divided by z2 is equal to 3 minus 2i divided by 6 plus 4i. Have to take the conjugate, that's equal to 3 minus 2i divided by 6 plus 4i into conjugate of 6 plus 4i is 6 minus 4i, 6 minus 4i divided by 6 minus 4i, that's equal to multiply both the terms. So 3 minus 2i into 6 minus 4i divided by, so use the formula, so 6 square minus 4i square, that's equal to, so multiply 3 into 6, 18 minus 3 into 4, 12i minus 2 into 6, 12i minus 2 into 6, 12i minus the minus plus 2 4s are 8i square divided by 36 minus 4 square, the value is 4 4s are 16, 16i square. That's equal to 18 minus 12i, minus 12i, the value is 24i. So minus, here my square value is minus 1. So minus 1 into 8 divided by 36 minus with minus plus 16. So that's equal to 10, 18 minus 8, the value is 10 minus 24i divided by 36 plus 16, the value is here 2, 12, 52. That's equal to 10 divided by 52 minus 24 divided by 52 into I. We can cancel this term. What is the value we get? For second table. So here 5, 26, this term 12, here 26, again we can cancel for 2 table. So 1, 3. That's equal to 5 by 26 minus 6 by 13, 5. So this is the answer. This is the answer for example 2.6. Homework. Exercise 2.3. First, second part, then second part. Page number